Good day, my dear grade 7 students. So how are you today? I'm hoping that all of you are doing fine and safe at home. So for today, we're going to discuss about the measures of variability, specifically the range and the mean deviation. The measures of variability. So the measures of variability put meaning into the entire distribution. The measures of variability, or sometimes called measures of dispersion, describe how varied, clustered, or dispersed the observations are in a given set of data. So what can you see or what can you observe in this given? So let us consider these two sets of data, wherein we have set A, where it considered 80, 81, 83, 84, 85, 87, 88. While set B, we have 75, 77, 79, 84, 88, 90, and 95. So of course, as you would notice, if we are going to find for the central tendency, the mean, the median, and the mode, so the mean is 84. And then of course, the median here, or the middlemost value is 84 also. While the mode is also 84 because 84 occurs 2 times. Well, in set B, where we have 75, 77, 79, 84, 88, 90, 95, wherein the mean is also 84, the median is 84, and of course our mode is also 84. We can present data using number lines with arrowheads positioned at the lowest and highest observations to see how different they are. In the number line below, the values in set A are clustered between 2 neighboring arrowheads. As you would notice, so we have here 80, and then of course the highest value is 88. So this will be the number line. Now you will notice in this set B, we have the values which are scattered between 2 distant arrowheads. So as you would notice, so we have here 75 and then we have here 95. So they are distant from each other. See, in this picture, the measures of variability will help us understand their differences. So in set B, so they are greatly differ from each other, while in set A, they are slightly different from each other. Start the measure of variability with the range, the mean, or average deviation. When we say range, this is the simplest measure of dispersion. The range, denoted by capital letter R, is the difference between the highest and lowest observations in a given set of data. It is also describes only the arithmetical spread of the observations in the entire data. When we are going to find for the range, we are going to use this highest value, denoted by H, minus the lowest value, denoted by L. Consider this example, wherein we have set A such that 80, 81, 83, 84, 85, 87, 88. Let's find for the range. Highest value, what is the highest value, and the lowest value. So we have here 88 as the highest value and 80 as our lowest value. Subtract. So therefore, our range is equivalent into 8. Have another example. So where we have set B, 75, 77, 79, 84, 88, 90, 95. So the highest value minus the lowest value. So of course, our highest value is 95 and the lowest value is 75. So therefore, our range is 20. Class, take note. Note class that only 2 observations per set are used in finding for the range. Now, let's proceed into the mean deviation. The mean deviation refers to the average of the absolute values of the differences of the observations from the mean. Note that all observations are included in determining the mean deviation. Hence, this is more reliable than the range. Let's find for the mean deviation for the ungrouped data. So the formula that we're going to use is the mean deviation is equals into the summation of the absolute value of our x minus our mean all over our sample size. So when we say x, that is the value or score of the distribution, and then we have the mean of the distribution and the number of observations. First, when you are finding for the mean deviation of the ungrouped data, so these are the steps that you need to follow. We're going to arrange the values according to the magnitude from least to greatest value. And then second one is you need to solve for the mean. Then find the deviations, where you need to subtract your given value minus your sample mean, and then you need to get the absolute values of the deviation in step 3. Then find the sum of the absolute values in step 4, and for final step, you need to divide the sum of the absolute values by n, or our sample size. Let us consider this given example wherein you have the given set such that 75, 77, 79, 84, 88, 90, and 95. So we have here now arrange the values according to magnitude. So you need to arrange the scores from the lowest value up to the largest value. So we have 75, 77, 79, 84, 88, 90, and 95. And for the second step, you need to solve for the mean. So the formula that you're going to use is the summation of your x to be divided by the sample size. So therefore, you have here 672 as the summation of your x, or your sample, or your observation. So 672 divided by 8 as your sample size. So therefore, you have the mean as 84. Okay, so for step 3, we need to find for the deviations wherein we need to subtract our observation and our mean. So the mean that we have that we get earlier or previously is 84. So we need to subtract our mean to the given score. So of course, 75 minus 84, that is negative 9. 77 minus 84, so you have negative 7. 79 minus 84 is negative 5. 84 minus 84 is 0. Then 84 minus 84 is 0. 88 minus 84 is 4. 90 minus 84 is 6. 95 minus 84 is 11. For a total of 0. So you need to get the summation of this column. And then for your step 4, we need to get the absolute values of the deviations in the step 3. So we are going to have turn negative into positive. So third column table. So get the absolute value of your negative 9. That is 9. Negative 7 is 7. Negative 5 is 5. 0, 0, 0. Then we have 4, 6 to 6, and then 11. So that will be the absolute values. Therefore, we need to find the sum of the absolute values. So get all the sum wherein you have here the absolute the summation of the absolute value of your x minus your mean is equals into 42. Of course, after that, for your step 5, you are going to divide the sum of the absolute values by your sample size to find for the mean deviation. So you have your 42 to be divided by 8. So therefore, you have 5.25 as your mean deviation. Okay, so that is how you are going to find for the mean deviation and the range of the ungrouped data. So thank you for listening. God bless and stay safe.